Oh. All right, sweet. We are live. Last week, that's exciting.
Yeah, that is exciting.
And it seems to be a pretty easy week, so not too bad.
Yeah, it wasn't bad at all. I actually got everything done last weekend. It wasn't bad.
All right, cool. So number one, when sound passes through one medium to another, where its propagation speed is different, does its frequency or wavelength change? Explain your answer briefly.
I said speed of sound is dependent on oscillation. So I can't read that. So as the speed of sound changes, speed of sound, the wavelength also changes. Can't read my own handwriting.
That's what I said.
Yeah, like that.
Okay. I said the frequency, but I wasn't really sure on that one.
So wait, sorry, what did you say?
So I said the frequency changes.
I said wavelength will change, frequency does not change. Is that what other people got?
Yeah, I can see how the wavelength would.
Okay, sweet.
Cool. All right, number two, a physicist at a fireworks display times the lag between seeing an explosion and hearing its sound and finds it to be 0.4 seconds. How far away is the explosion if air temperature is 24 Celsius, and if you neglect the time taken for the light to reach the physicist? Calculate the distance to the explosion, taking the speed of light into account. Note that this distance is negligible greater. So I got 138 meters.
Yeah.
Cool. And then it's like 1.38 or 0.0974 meters. So it changes by, it was like a couple thousandth of a meter.
Yeah, I just did 3 sig figs on both of mine, so I just did 138 for both of them. But yeah, it would change a little bit. So
yeah, I was curious how much it would change, and it's like the 4th decimal place is where it finally changes. So not much. Okay, what is the intensity of sound that has a level of 7 decibels lower than a 4 times 10 to the negative 9th watts per meter squared sound? What is the intensity of a sound that is 3 decibels higher than a 4 times 10 to the negative 9th watts per meter second squared, or meter squared sound? So for A, I got 7.98 times 10 to the negative 10th. And then the second one, 7.98 times 10 to the negative 9th. Is something different?
I didn't do that one.
Yeah.
Yeah, so the first one, I got 29 decibels. I think. I kind of did this quickly and not super well. And B, I got 39 decibels. But under, I say 3.9 e to the negative 9th. So I don't know.
Yeah, so that's exactly what I got for decibels.
Okay, cool.
So, because it is asking for the intensity of the sound, not just the whole intensity. So it would just be in decibels.
Sweet.
Yeah. So, do you guys know how to do that one? So this one is just, there's that equation of the beta equals 10 decibel, 10 times log of the intensity over the threshold intensity. So then we're given the intensity in this one. So all we have to do is 10 times the log of the intensity given divided by the intensity of hearing, which is just a standard 1 times 10 to the negative 12th. That one's not too bad. Number 4, is the Doppler shift real or is it sensory illusion? Definitely real.
Thought that was kind of funny.
Yeah. It's like, is it a fake thing or?
Oh.
Yep. It was actually interesting to look at it. It makes a lot of sense, like how it works. So,
Yeah.
kind of cool. Number 5, a spectator at a parade receives an 888 hertz tone from an oncoming trumpeter who's playing at an 880 hertz note. At what speed is the musician approaching if the speed of sound is 338 meters per second?
I got 3.05 meters per second.
Yep.
That's what I got as well.
Sweet. Number 6, what is the difference between an overtone and a harmonic? Are all harmonics overtones? Are all overtones harmonics?
So I said all overtones are harmonic, but all harmonics are not overtones.
Yep.
Yep, because the fundamental frequency is a harmonic, but not an overtone. Number 7, a student in a physics lab are asked to find the length of an air column in a tube closed at one end that has a fundamental frequency of 256 hertz. They hold the tube vertically and fill it with water to the top, then lower the water while a 256 hertz tuning fork is run and listens for the first resonance. What is the air temperature if the resonance occurs for a length of 0.336 meters? B, what is the length that they will observe the second resonance or the first overtone?
So temperature, I said 5 degrees Celsius.
That's what I got.
Cool beans. I got 22 Celsius.
I got 295 Kelvin. That's in Celsius.
Yeah, so 295 Kelvin is 22 Celsius.
Oh.
Uh-oh.
Yep, you're right.
So how'd you guys do that?
So I got the velocity, which is 4 times 256 times 3.336.
Mm-hmm.
And then that's 334.06. And then I divided that by 331 times 273. And then I subtracted 273 from that, which got me 5.
Yeah.
Subtract. So the way I did it was I used the formula of the velocity equals 331 square root, and underneath the square root is the temperature divided by 273, and the temperature is in Kelvin.
Yeah.
So then I still got the same. So it's the 344.064 for the velocity. It's just 256 times 4 times 0.336.
Okay. I probably plugged in the wrong value for the denominator. It looks like.
What do you guys get for part B? Did we do that yet or no?
Yeah, so part B I got 1.008 meters.
That's
Okay,
what I
that's what I
got.
got too.
Got that as well.
Sweet. Are we good on 7, or do we want to just move on?
I don't really care which one's right. I got 295 Kelvin. I don't know if that's right or not.
I'm down to go with whatever you guys got. I'm good with that.
But me and Nathan got the same thing, so that means something.
Yeah, I just used the formula that was in the book.
That's what I did, yeah.
Okay.
Okay, so number 8. What are the loudnesses of fawns of sound having frequencies of 200, 1,000, 5,000, 10,000 hertz? If they're all they are all at the same 60 decibel sound intensity level. If they are all at 110, and if they're all at 20. So that one was just a chart. So for the 60, it's 200 is 50, 1,000 is 60, 5,000 is 60, and 10,000 is 60. For the 110, the 200 is 110, 1,000 is 110, 5,000 is 120, and the 10,000 is 120. For the 20, 200 is 0, 1,000 is 20, 5,000 is 20, and 10,000 is 10. Get any different? Cool.
That's good.
Yeah, that one would have been nice to just have like an equation. You just plug it in.
Yeah.
But it's like, I'll just look at the chart.
Yeah.
Okay, number 9. A diagnostic ultrasound echo is reflected from moving blood and returns with a frequency 500 hertz higher than its original 2 megahertz. What is the velocity of the blood, assuming that the frequency of 2 megahertz is accurate to 7 sigs and 500 hertz is accurate to 3?
0.192 meters per second.
I got 1.54 e to the third meters per second, but that's freaking fast. So I don't think that's true.
I got even faster. I got 6.78 times 10 to the 6th.
Whoa.
Yeah.
I got 1.54.
Hey, I got the same numbers as you.
Don't go. Two of you guys match up.
Go with that one.
Sure. Yeah.
I don't care. Yeah, just someone turn it in. I don't even care at this point.
No.
Yeah.
No. Honestly, no. So I think Michael, you got all the ones that are right. You can just submit yours.
I think me and you did, but yeah, I could submit it. That's fine.
Okay. Because I didn't get the last one right. Otherwise, I would do mine.
All right, well, guys, have fun.
Yeah.
Fun.
Yeah,
Have fun.
Good luck with finals.
Right. Good luck on the test. Should be easy, hopefully.
Yeah.
Yeah, it's not bad. All right, see you guys.
See ya.